So trigonometric functions of angles, all right? So let's draw a picture. Talk about what we're meaning here. Okay, so I've got my circle, my unit circle, so this point is 1, 0. Now, we have defined our trigonometric function as evaluating a trig function, plugging in a real number t. Okay, so say we go out some t distance here to this point p of x comma y. Okay, then what have we done to get the x value and the y value? That point is cosine of t comma sine of t. The x value is the cosine and the y value is the sine. That's what we've done. Now what I want to do is I want to create a central angle whose initial side starts here on the positive x-axis and it extends out the other ray side, goes this way, and this angle here is theta. Now since I know this is a unit circle and I have my formula S equals r theta, right? My arc length here is t, the radius is 1, and so t is equal to theta, the angle in radians, okay? So it's the angle theta is t radians. Now, a point P on the unit circle that corresponds to the real number t is also a point P on the terminal side of the angle theta equal to t radians. Okay, so as a result, that sine of t, okay, where t is some real number, okay, plugged in here, this is the same thing as sine of theta, okay, where theta is equal to t radians. Okay, this angle, so and so on and so forth. You can do it with the cosine and the tangent. Now, we can define the trigonometric functions of the angle, okay? So, one thing that I do want to note, so if an angle's measured in degrees, then they're going to give you a degree symbol in this textbook. They're going to say sine of 30 degrees, okay? But if it's in radians, if they said sine of 30 and that's it, this is 30 radians, okay? This is 30 degrees. So if you don't see the degree symbol, then we assume radians. No degree symbol, assume radians. Okay? So like you could have like the sine of pi over 6, right? That would be no degree symbol. That's radian form. Okay, it's pretty easy to convert between degrees and radian. The only thing that we have to do is we have to take that 30, right, to convert to radians and multiply by pi over 180, right? And if I multiply through, I get pi over 6, and that's the radian form, okay? All right, so what we want to do is we want to find exact values of trigonometric functions on the quadrantal angles, okay? So where it's at 90, 40, 90 degrees, 180, 270, and 360, okay? So let's draw circle. Okay, so I want to find the exact values of the 6 trigonometric functions for theta equal to 0 degrees, theta equal to 90 degrees, theta equal to 180 degrees, and theta equal to 270 degrees. Okay? So for the first one, all right, if I draw a circle at 0 degrees, okay, where am I at? On a unit circle, this is 1, 0, okay? So this is 0 degrees. Now, if theta equals 0 degrees, that's 0 radians, okay? So the sine of 0, all right, well, I've traveled no distance there. So sine of t, the sine of theta, this is the y value here is 0, okay? The cosine of 0, that value there is 1. Now, the tangent of 0, remember this is your sine 0 over cosine 0. So that's 0 over 1, which is 0. Okay? Let's do the other ones. Cosecant 0. Cosecant 0, remember this is y, 1 over y, the reciprocal. So that's 1 over 0. That's undefined. So undefined. Secant 0, this is 1 over x, which is 1 over 1, which is 1. That's okay. And then cotangent 0, this is, I think it's x over y, which is 1 over 0, which is undefined again. Okay, so those are the 6 trigonometric functions evaluated at the first quadrantal angle. Okay, what about right here? Okay, at 90 degrees, at theta equal to 90 degrees, which theta equal to 90 degrees, let's think about this in radians. That's 90 times pi over 180. So this is 90 divided by 180 is 1 over 2. So that's pi over 2. So that's pi over 2 right there. Okay. So I rotate up from my initial to my terminal side is 90 degrees. This point right here on the unit circle, I go 0 in the x direction, but I go up 1 in the y direction. And so what does that tell me? That tells me that the sine of pi over 2, what is this equal to? That is going to be the sine of 90 degrees, which is the y value, which is 1, okay? The cosine of pi over 2, which is the same as the cosine of 90 degrees. This is equal to, well, the x value is just 0, okay? Tangent, now I don't need to keep writing unless it asks you to write the radian form and the degrees form, okay? I can just pick one of them and go with it, okay? So pi over 2, tangent of pi over 2 is what? It's the y over the x. What is the y value? That's 1 divided by the x, 0. This is undefined, okay? That's undefined for tangent. For cosecant pi over 2, this is 1 over y. That's 1 over 1, which is 1. Secant pi over 2, this is 1 over x, the reciprocal of cosine. That's 1 over 0, which is undefined again. And then the last one, cotangent, we'll just say 90 degrees for funsies. And that's the reciprocal of the tangent. So instead of y over x, it's x over y. This is going to be 0 over 1, which is 0. Okay? So Those are your 6 trigonometric functions there. What about at 180? Well, 180 degrees. Okay, we've got a circle. Okay, I start here on my initial and I rotate 90, and then another 90 makes 180 degrees. So this looks like a straight line. So where does the point XY end over here? This point here is -1, 0, since remember my radius is 1 for a unit circle. Okay, so then I find my origin at 0, 0, like always. That's where that central angle is located. Now 180 degrees, theta equal to 180 degrees. This in radians is 180 times pi over 180, which is just pi. Okay? So the sine of pi, what's the y value here? The y value is 0. Cosine of pi, what's the x value? The x value is -1. The tangent of pi, what is this going to be? Well, it's the y divided by x, okay? That's going to be equal to what? That is going to be 0 divided by -1, which is 0, okay? Well, let's see, cosecant, this is the reciprocal of sine, 1 over y, so that's 1 over 0, that's undefined, okay? Cotangent and secant, we'll try to stay in order here. That's 1 over x, which is 1 over -1. The x value is the -1 value. The y value is 0. This is -1. And then cotangent, this is x over y, the reciprocal of tangent. And that's going to get you -1 over 0, which is undefined. Okay, one more to go. One more to go here. We got it. We're almost there. The last one here, I rotate 270 degrees. So I'm down here at this point here. This XY coordinate is 0, -1 for that unit circle. Okay, so this is theta equal to 270 degrees. Now 270 in radians, that's going to be 270 times pi over 180, which gets me 3 pi over 2, okay? So the sine of 3 pi over 2 is equal to, well, what's the y value? The y value for this part is -1. Okay, cosine 3 pi over 2. What's the x value? The x value is 0. Okay, tangent theta. Sorry, let's do tangent 3 pi over 2. This is equal to y over x, which is -1 over 0. That's undefined. Okay. Cosecant, let's just say 270 degrees. It's okay to swap between those two unless it tells you to use radians or degrees. Cosecant is the reciprocal of sine, so that's 1 over y, so that's 1 over -1, which is -1. Secant, 270 degrees, this is 1 over x, that's 1 over 0, that's undefined. And the last one, cotangent of 3 pi over 2, doesn't matter again, just pick one. And then it's x over y, which is what? That's 0 divided by -1, that gets me 0, okay? So that sums up all the 6 trigonometric function values on the 4 quadrantal angles here, 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 and here. Okay, so make sure that you get those down. Those are definitely important. We're gonna use those frequently, okay? Now, the thing is, if we have, multiple values, we can have radians that are different radian lengths, and you can still get the same answer. So what do I mean by that? So say you've got like a circle like this, okay? And say you're asked to calculate the sine of 3 pi. Okay, well, what do you know about a circle unit? Its radius is 1, so the S, that's 2 pi r, right? That's the circumference. So if the radius is 1, then to rotate all the way around is 2 pi radians. So if I'm traveling 3 pi radians, that means I'm going to go through a circle and then back around again. So my angle, okay, so I start here on my initial side. I rotate all the way through 2 pi amount, okay? But once I go through 2 pi, I still have how many pi's left? Well, I started with 3 pi's and I've went through 2 pi, so that leaves me another pi. So I need to do another pi's worth spin, okay? And so that gets me over to here. So that point right here is -1, 0, okay? So what is this telling me? All right, to find this value, all we need to do is take out one of those cycles, okay? So just take away, subtract 2 pi from this, okay? So sine, now if I subtract 2 pi, this becomes the same thing as sine of pi, all right? And you can repeat this game however many times that you need to repeat it. Okay, so this is equal to what? The sine is the y value, so that's equal to 0. That's the y value for that part right there. So what if it was like a negative? Okay, so we haven't done negatives, so let's try that. Like the cosine of negative, let's say negative 90 degrees. Okay, what is the cosine of negative 90 degrees? So let's draw a picture here. Okay, now a positive angle, we've talked about a positive angle. With a positive angle, we rotate counterclockwise. That's a positive angle. But with a negative angle, we rotate clockwise. So now I'm going to clockwise rotate 90 degrees, and where do I end up? I end up right here. What is the xy coordinate here? Well, it's 0, -1. So the cosine of 90 degrees negative is going to be what? It's the x value, which is 0 here. Okay, so just remember, if it's a negative, you're going clockwise rotation. And if it's a positive, then you go counterclockwise. Okay, so just to drive this home, to make sure we understand what's going on here. Say I had like, I don't know, 13 pi over 6. Okay, so 13 pi over 6. Now, if I was going to do this, one, sine of 13 pi over 6, what would go on here? Well, 13 pi over 6. That, my friends, looks pretty weird. So what could I do here? Well, the circumference of the circle for a unit circle is 2 pi. We talked about that. It's all the way around is 2 pi. So I could look and I could say, how does this differ from 2 pi? Well, 2 pi with a denominator of 6, so I'm going to multiply top and bottom by 6. That gets me 12 pi over 6. So it looks like this is just a little bit bigger than 12 pi. What is it really? It's really what? 12 pi over 6 plus pi over 6, right? So what did we say? This thing, when we have a pi over 2, it's like we start here and we go all the way around and we're back to where we started. So once we're back to where we started, it's like we can just eliminate that first part. So all we have left is the pi over 6. So this is equal to sine of pi over 6. Now we've got a problem with sine of pi over 6 because if we did, so pi over 6, just to give you an idea, that's 180 divided by pi. That's like 30 degrees. So 30 degrees kind of looks like that. This is in a quadrantal angle, okay? So it's not one of those that we just figured out. So we're going to have to come back to this one in another video, and I'm going to show you how we're going to figure out this using triangle tricks.